All right, today we're going to go over tractor history and a couple different types of tractors. This is really kind of dealing with chapter 1 in the book, which I know some of you were having trouble finding, and so we're not going to actually have you require that text, but we're going to just kind of go over the stuff that essentially is in that chapter 1 there. So we'll go ahead and we'll run through this. So to define a tractor, basically we're talking about an agricultural or an industrial machine. Obviously in this class, we're going to be focusing a little bit more on the agriculture tractors, although there are some industrial tractors that we will be using in this class. But a tractor is going to have not necessarily all of these, but most of these basic kind of components that is going to be attributed with them. So it's going to be self-propelled, so it's not going to be being pulled by something else. It's going to be able to produce drawbar pull, so we can haul trailers and different things like that. Can have either belt or PTO. Belt is going to be like an older kind of style, but PTO nowadays, that's pretty much the standard for tractors that we are going to use. Has clutches to disengage and engage the power, can go in reverse, is steered by the operator, has hydraulic capacity. Not all tractors are going to have that. You're going to find that out in class. If you're looking at this after lab, you'll see the tractors that we operated. If you're looking at this before lab, the tractors that we will be operating in lab this week are not going to have any hydraulic capability of plugging something in auxiliary hydraulics. So they may or may not have those things. And then the last one is going to be a 3-point hitch. Most tractors are going to have a 3-point hitch. They will vary. There are different categories of hitches, and we will cover those in later classes. But basically, those components, some kind of combination of some of those things, that's something that we're going to identify and define as a tractor. So in the pre-1800s, all farming operations were conducted by hand or animals. So we had plows that were horse-drawn plows, and we were, pushing things down by hand, or we were literally just taking tools and farming by hand. Obviously, that's not efficient. You can't grow as much food that way, and it takes more people to do that. But back then, that's what we had. Most people were farmers. Most people did that to be able to provide the food. In the 1850s to the 1900s, that's kind of when the steam tractor was really kind of prevalent, but didn't have the power really that the internal combustions had. That really kind of came about in the 1900s, and that's really when things kind of started to take off. So just last century really is where tractors really kind of took off. We're going to kind of go through the history of this stuff, but there's a lot of different things on here. I'm just going to kind of cap a couple of those. I'm not going to spend a bunch of time on there. You guys can read this. This PowerPoint will be posted, and you can read this and go through a little bit more in depth if you're kind of curious and you want to know more. So I'm just going to kind of touch probably on each slide, just maybe 1 or 2 points, on these things. So steam engine, right? It was patented in 1769. So it was there, but it really didn't kind of take off. The idea was there, but they didn't really know how to implement that, until really 1849 when they kind of, were able to make it kind of portable. So everything was kind of done before, was all kind of stationary type work. And then once they were able to make it portable, that's when they figured out, hey, this can be used in place of a horse to really do that work and make things a little bit better than horse-drawn stuff. In 1855, the steam plow, self-propelled steam traction engine was created. You can see a little picture of that stuff there. Then in 1892, Rudolf Diesel patents the diesel engine. So when you hear the diesel engine, it's the reason we call it a diesel engine is because of this guy, Rudolf Diesel, who patented that engine, which, kind of was taken off after the steam engines, trying to figure out different ways, better ways to be able to, operate and make things better. And that's really what, a lot of, industry is about, is how do we improve things? How do we make things better? In 1992, the first gasoline engine was, manufactured by the Waterloo Boy and the John Deere tractor line. So John Deere, pretty common name. Waterloo on the older tractors, you may see that, but nowadays you really don't see that. But John Deere obviously is still very prevalent. In 1892, we also had the first Case tractor, Case IH International. You're going to find that there's a lot of these companies that basically kind of mix and match, and sometimes they were joined together, then they kind of separate, and some just kind of absorb other companies and kind of go in there. 1897, we have McCormick tractors, which those ones are still around, at least, like 10 years ago, there were some new ones being built, but I don't know if they've gotten absorbed by another company. In 1906, we have international harvesters that have come up in 1899. So a lot of those companies, like I said, they kind of joined together. They weren't really called tractors until 1906. That's when they actually used that term, tractor. And then obviously that stuff has stuck because now the name of this class is the tractors class. In 1917, the first water ballasted tractor. Ballast is actually a really important thing in this class, and we are going to talk a little bit about that and how we ballast tractors. When we talk about terms of ballast, we're talking about putting weight in different spots to help make sure that that tractor can get the traction that it needs, that it's not going to tip over, that it can actually pull a little bit more weight. And so in 1917, we kind of did that and went through. In 1919, they first integrated in the International Harvester, the PTO. The PTO is the power takeoff. If you did the tractor lab from last week, you should have seen that on the tractors. You'll see them on the tractors that we're going to operate as well. And then kind of the other thing that's important, in 1920, we had the first Nebraska tractor test. What that is a test that they use to determine horsepower, both PTO horsepower, drawbar horsepower. It's really kind of a rating system that we use on tractors to determine how much power and force and all that kind of stuff that a tractor has. It's kind of like the standardized test that we put tractors through. 1927 PTO was standardized by the American Society of Agriculture Engineers. So that way, PTOs could be utilized between, different manufacturers, different equipment that's going to attach to there, because sometimes what you can do is you can have a piece of equipment, but if you have a, tractor that's different, they may not match up. So they standardize those things. In 1928, the first mechanical power lift on a John Deere 1020 tractor was created to be able to have that lifting. We're going to talk a little bit at kind of midway through this PowerPoint about four-wheel drive tractors, mechanical front-wheel drive tractors, and two-wheel drive tractors. But in 1930, Massey Harris, if you've heard of Massey Ferguson, those are different tires. These are companies that are kind of moving and joining up with each other. But they created in 1930 the first four-wheel drive tractor. In 1931, BF Goodwrench created the zero pressure rubber tire. So it's a solid rubber tire that allowed for tires to not get flats, to not have to worry about that. In a car, we don't want solid rubber tires because we want that pneumatic pressure to kind of give us a little bit of that cushion. But on a tractor, we're not so concerned about that. We're concerned about pulling stuff through a field. So in 1932 is when they first created the pneumatic tire. And then I skipped over 1931, where the first diesel tractor was produced in the United States by the Caterpillar company. So Caterpillar, okay, another big name, still around today, one of the bigger manufacturers, especially on the industrial side. Caterpillar definitely has a market, cornered on the industrial side of things. John Deere's a little bit more prevalent on the agriculture side of things, although John Deere does do industrial tractors as well. So the first 3-point hitch, and that's going to be what we either hooked up in lab, depending on when you're watching this, or you are going to hook up in lab. There's that video that you're going to watch on that as well. But a really prevalent piece of equipment, 3-point hitches are pretty much on every tractor that you see. And then in 1939, the first LP gas, that's liquid petroleum or propane tractors, were first introduced. They still do use some today, but most common nowadays is actually diesel engines. They do have a lot of gasoline engines. A lot of older tractors were gasoline, but newer ones nowadays, pretty much the standard is diesel engines. Although you do see, some gas, and you do see some propane engines as well. In 1952, first power steering was on tractors. In 1958, we had high-low range to give us different gear selections to be able to mitigate different, things that are in the field. Sometimes you want a little lower gear, you want to run a little bit slower, you need that, horsepower to actually be, given to the tires to be able to pull a piece of equipment through the field. And sometimes you just need the speed. If you're spraying something and you've got a trailer that has wheels behind and you're not creating a lot of drawbar force power on it, you can run with something that takes a little bit less power to the wheels versus something like disking that takes a lot of power into the wheels. 1958, the first fully power shiftable transmission was introduced, closed center hydraulics in 1961, and then hydrostatic transmission in 1967. We have more things, obviously, that have been advanced in past 1967, but that's kind of where our book kind of really leaves off a little bit. And we really are going to deal with a lot of those things as we get through and see the different tractors, different equipment that we're going to be operating in this class. When we talk about tractors, there are really kind of two main types of tractors, and those things get broken down even farther. We have crawler type tractors, which are the track ones that you can kind of see right up here. And then we also have wheel type tractors. And I don't know why both of these things say number one. Whatever, they're 1 and 2, either way, that's a typo. But there's crawler tractors and then there's wheel tractors. In this class, we're really not going to deal with crawler tractors. We're really going to be kind of focusing on wheel tractors because that's more of what we see and more of what we use. I don't even think we have a crawler type tractor here at Fresno State. So yeah. So when we talk about wheel tractors, we can identify them by 3 different kind of categories. And those categories are two-wheel drive, front wheel assist or MFWD, and then four-wheel drive tractors. Okay, and we may have talked a little bit about front wheel mechanical assist or mechanical front wheel drive or the front wheel assist, but we're going to kind of explain it a little bit more in here as well. So when we deal with two-wheel drive tractors, we can identify these things as like pulling tractors. They're larger tractors, larger rear wheels, smaller front wheels typically are going to be on the front. Kind of like you can kind of see here, this is obviously a little bit older tractor, but the things still, same things still do apply. They do make tractors right now that are two-wheel drive for situations where you just don't need that extra weight. You don't need that extra pulling, that extra power there. When we deal with these two-wheel drive tractors, we kind of categorize them even further down as either a standard tread, a row cop, a high clearance, or a low profile tractor. Some of these two-wheel drive tractors also can be considered mechanical front-wheel drive tractors as well. It really just depends on what type of equipment is on there, but they do kind of fall under the same, kind of categories as these. So when we talk about standard tread tires or standard tread tractors, they're going to be used where we have large areas of the same crop. Typically you're going to see a lot of these things kind of Midwest. You might see, if you're doing, alfalfa or corn or things like that, you're going to see a lot of these, kind of two-wheel drive tractors that are going to be in there. We also call those things wheatland tractors. The front ends are not required, are not adjustable, meaning you can't space out the tires on the front end of these things. They're going to be stationary. You've got stationary axles. We can't adjust those things. Some tractors, we can adjust those axles out. We can change some things and change the tire width. The only reason we would want the tire width to change is if we are doing things that would require rows. But if you're doing like an alfalfa, which is probably the best example, you basically are driving over that crop with an alfalfa, so tire spacing isn't important. If you are dealing with things like corn, tire spacing becomes a little bit more important because you do not want to run over that corn plant. Corn will die. It does not hold up well to being driven over, and it would kill your crop. And so depending on your spacing and stuff, you would need to adjust your tires. On the standard tread, you can't do that. With the row cop track tires, you can do that. You can adjust these wheel spacings a little bit and to make sure that, you're not going to run your crop over. You could have a typical four-wheel drive tractor, or you could have a tricycle type tractor, like you can kind of see on this bottom side right here. Some of them might have a dual wheel. Some of them might have a single wheel. That's going to be your steering wheel. And that could basically go down that row. Your back tires are going to adjust for whatever your width of your row spacing is. And you drive down into the furrows. And these ones, basically, you can make those adjustments. So that way you can drive down a row crop product there. So corn, probably the best example that we can give there, but maybe even like a cotton or something like that where you don't want to run those things over. High clearance tractors, you can see these ones, basically they've got larger tires on there. You're going to have that higher clearance underneath that tractor, so that way you can have operations and do operations while that crop is going, while it's growing and getting bigger. Once stuff gets too large and that tractor would hit it, you can no longer take that tractor through. That's where we kind of come in with some aerial applications and different things like that for sprays and whatnot to kind of help us with that. Unlike tree crops and things like that, or vines, we can't drive in between the rows because the rows are spaced too close together. So high clearance tractors are really important to be able to proceed with operations as things are working. Low profile tractors, these are the ones that are going to be able to drive in through between vineyards and between orchards. Wheel spacings are going to be quite a bit smaller, so that way you can fit in those. They do have varying sizes on these things based on, what type of application. Are you driving it in a vineyard? Are you driving it in an orchard? And even orchards can have, a large varying space depending on what type of crop we have, but we can operate these tractors. We can drive them between the rows, so that way we can perform different operations like sprays, mowings, diskings, all those types of things. Oh man, I went too fast. All right, front wheel assist. This is also known as mechanical front wheel drive. These are very similar, like I said, to the two-wheel drive tractors, but the difference is that we can have power be delivered into these front tires. Most of the two-wheel drive tractors, they are driven by the rear tires, and the front tires have no pulling force at all. With mechanical front wheel drive or front wheel assist, we can actually engage a lever, and that is going to engage these tires in conjunction. Because these tires are different sizes, these front tires are actually going to spin faster than the rear tires, which is why we never run with mechanical front wheel drive when we're on the road. You can also identify these things. One, it's going to have a beefier axle in the middle, but the other side is really just kind of the design of the tires. These tires are called angle bar tires. And if it's got the angle bars, typically you see them on the back, but if it's got them on the front, they're not kind of smooth and round. Typically that's going to mean that it's a mechanical front wheel assist, because you wouldn't need to put tires like this on unless it had the ability to have some pulling force. So if you're in a tough area, in a muddy area, this mechanical front wheel drive can help get you out of that area. Four-wheel drive tractors are a little bit different than mechanical front-wheel drive tractors. Now, when we think about in terms of a four-wheel drive vehicle, if we talk about, let's say, a truck that is a four-wheel drive vehicle, you can engage and disengage that four-wheel drive. That is more akin to mechanical front-wheel drive on tractors. When we use the term four-wheel drive, we're talking about something that is always engaged. So all four tires are going to be the same size on the tractor. And when you don't engage or disengage that four-wheel drive. So those tires are all going to be driving all at the same time. That is going to be more like if you've ever driven in an all-wheel drive car. An all-wheel drive car means that all wheels are always driving. There's no engaging or disengaging. They tune those things in to where they are spinning at the same rate, to where one tire is not spinning faster than the other, and it doesn't create damage or wear on the tires. Four-wheel drive tractors are the same way. So you cannot disengage a four-wheel drive tractor. It is always there. If you can disengage and engage the four-wheel drive, that's actually a mechanical front-wheel drive on a tractor. So it's an easy way for you to identify, is that stuff there? Is there an engagement or not? Okay, if there's not, it's a four-wheel drive tractor, because it's always going to be driving. We kind of put these things into two different categories on a four-wheel drive tractor, and these ones are a little bit different than the two-wheel drives and the mechanical front-wheel drives. They are categorized as either a steering axle, and we'll explain this on the next slide, or they're categorized as an articulated one. And for some reason, students always kind of mess some of these things up. And so we want to make sure we kind of emphasize some of these things and really kind of show you what the articulated one is, because a lot of students have trouble kind of identifying that. So I'm going to spend a little bit of time explaining that. But first, we're going to go to the steering axles, and we're going to kind of see what these ones are like. So we've got numbers, right? 1, 2, 3, 4, right? We got four-wheel, crab, front wheel, rear wheel. And then we've got some pictures that are on the side, and it's kind of hard to see these things. These are pictures that are pulled from your book. We've got number 1 right here. We've got number 2 right there, number 3, and then number 4. Okay. And again, this picture is not the greatest because it is pulled from the book. But the way that these things actually steer. So on this stuff, we have, kind of a traditional axle where the tires are going to turn. If you think about a vehicle, most vehicles have the front axle is going to be your turning axle. So the tires, when you turn the wheel, they're going to turn side to side, right? On a four-wheel drive, just a standard four-wheel drive tractor, both the front and the rear axles are going to turn. When you turn the steering wheel, they're going to turn opposite of each other. So the rear wheels are going to turn opposite of the front wheels. You can kind of see that depicted in this picture, how they are at an angle on the front and then an opposite angle on the rear. The way that these things are designed, it really just depends on manufacturer. It depends on kind of what you're looking for. They do operate a little bit different, and it is something that you have to kind of get used to when you're operating. But just understand the way that the axles work is going to be a little bit different. On a four-wheel drive, they're going to turn opposite. The rears are going to turn opposite from the fronts. On a crab tractor, you'll notice these ones are both turned to the right, but notice the fronts and the rears both turn in the same direction. So you got all 4 of them that are kind of turning at that same time. So you don't have a tire that's essentially following it and trying to loop it around. It's literally just going to kind of turn itself because all 4 tires are turning the same direction when you turn that steering wheel. We have a front wheel drive. This is probably pretty standard to what you would see on most vehicles, where the 2 rears, this one should be white and that one should be right because they do not turn at all. That is a straight axle that does have power, and only the front ones are going to be turning. Okay. So again, most vehicles, this is probably what people are used to. And then number 4 is the rear wheel. You'll notice the 2 fronts, that is a straight axle. It does not turn at all, but the rear wheels will turn as you're turning that steering wheel there. There are some cars that have rear wheel drive. If we're talking about cars that have rear wheel drive, this is essentially the same exact thing that we're dealing with. Again, depending on what we're looking at, you may see certain things, on some tractors may just be the style, maybe where they're locating and what works better for operation in one area versus the other. But there's not necessarily a huge advantage to one versus the other. On an articulated steering, you actually have axles on the front, axles on the back. They are going to be stationary axles. Neither of these axles are actually going to be turning. To get the equipment to turn on an articulated four-wheel drive vehicle, you'll notice there is a little kind of connection right here. On this one, we've got this little bucket on the front, but there's a little connection. That connection has hydraulic cylinders that are essentially going to push forward one axle and pull back on the other, or sorry, let's say it's going to push on the right hand side and it's going to pull back on the left hand side. And what that does is it acts kind of like the front wheel drive, where it essentially turns that whole thing, but the whole axle turns, not just the tires on the axle. So whatever's attached on this end, you can see there's an equipment driver that's there and he's turning with it, or there's a bucket on the front, the equipment is attached to the back, but it's just using hydraulics to essentially turn it and push an axle forward, pull it back, and then do the same thing on the opposite side. These tires, by just natural of how things are connected and how things work, those tires will turn with it once the front ones kind of turn and you continue moving. These are a little bit different to kind of operate. We do have some tractors that are out here that are an articulated one. Some of our front end loaders, that's a real typical piece of equipment that you see that has an articulated front end. But when we're talking about articulated, that's what we're dealing with. We're not actually turning the axles. There's 2 straight axles that do not turn at all. And we basically use the body of the equipment to turn it around. Again, I kind of want to spend a little bit more time because I always think this is kind of a basic concept, but for some reason, this is a question that students always miss on some quizzes, on tests, on finals. They always tend to miss this question. So I want to make sure we emphasize this just a little bit more to help make sure that you guys understand that. If you still don't understand, please let me know. Send me an email. We can talk in class as well. And you can let me know and be like, hey, I still don't understand that. And I'll try to explain it in a different way. So that's all we're going to deal with today. I know I went through that stuff pretty quickly, but again, I don't want to bore you guys with all that history. You guys can look at that stuff. There's some major parts there. We've got some identifications of some tractors there. So thank you guys, and I will see you guys later.